Hello, good morning, everyone, and welcome to today's LinkedIn Live. I will start off by introducing myself. My name is Kishmala Imtiaz, and I work as a transport modeler and data scientist in PTV Group. Today, I'm also joined by our colleague, Jonathan Amayko from TomTom. Hi, Jonathan.
Hi, Kishmala. Thanks for having me here today.
Thanks for joining us today. All right, so I will start off with the presentation. Um, I will start off with our topic, and for a better understanding of our wider audience, I will start by explaining a little bit about what Model2Go actually is. So basically, Model2Go is a technology that is developed by PTV, and it enables us to create ready-to-use transportation models in just 1 week. We already have a product which is called Model2Go Supply in the market, and this product enables us to create multi-model transport supply models for any part of the world. Basically, the ideology behind this is that anything that can be automated should be automated. This product, it also includes the road network with the associated parameters such as the route types, the transport systems which are allowed on the route types, the speeds, the capacities. It also contains the public transport, the POI information. We can also have the structural data for the zones, and we can also generate the zones as well. For example, in this slide, I have shown 3 random examples of the Model2Go supply for different regions of the world. The top screenshots, they show the territory which is used to create the model, and the created model at the end, it contains everything that I just mentioned, the zones, the public transport, and private transport supply side of the model. So coming to the main topic of today's live event, this is Model2Go Demand. This is a new product which PTV is offering in collaboration with TomTom. And this new cloud-based process combines the smart model creation with the travel demand data. The OD matrices are powered by TomTom's reliable and scalable data. And depending on the geographical area of the world, the sample of the data sample size can vary between 10 to 30%. And what this product actually includes, in addition to the Model2Go supply, is the OD demand data. And what is the, in this slide, for example, I have on the screenshot, you can see that there are the zones which are created using the Model2Go supply. And these are created for the region of Paris. And I have uploaded these zones. So basically for these zones now, I can get the travel demand data using the TomTom Move portal. I will also show you what TomTom Move portal looks like in the upcoming slides. But for now, it is important to notice that the zones that are created in Model2Go supply can be used in Model2Go demand. And it is also important to note that we try to avoid small cell entries because we have to comply with the data protection guidelines, of course. Moreover, to what actually the data is and where it comes from, I would like Jonathan to invite and tell us a little bit in detail about the data. Please, Jonathan.
Let's go. Thanks, Kishmala. So we're here today, and as Kishmala was saying, you guys are going to hear a lot about the OD analysis, the TomTom OD, the origin destination. But what is important to mention is the data that powers TomTom OD is the TomTom GPS data that powers multiple products. So today we have a mix of automotive data and mobile GPS data. Of course, it's increasing a lot what we call it SDO data, which is sensor derived observations. Nowadays the cars are all connected with sensors, rain, potholes, lanes. So this is increasing a lot. If you click one more, Kishmala, and the question that we get all the time is, where do you get the data from? TomTom, we don't see those GPS in-car devices anymore. Now everybody uses mobile or the car. So where do you get the data from? And this is just to show that this is where we get the data from. Basically, if our partners and our customers are moving stuff, are on the road, we are getting GPS data as well. So big names like Uber, like Bolt, or all the automotive brands, we get that GPS data. And today we have more than 600 million connected devices around the world. So this is where the data come from, and it's a very, very big volume of data. If you click one more, Kishmala, and also the type of data that we work with, right? So the big majority, I have to say, of course, it comes from mobile data and automotive data, cars on the road, cars connected on the road. But it's still, there's a big mix of probe data. So we see the GPS data for sure, the SDO that we already talked about, the sensor derived observations. But we still, when we work with PTV, for example, with some city governments and road authorities, we get, for example, detector and hardware data. We also get input from city governments directly. But again, the great majority is the GPS data coming from our mobile customers and our automotive customers. The next slide is just to show a little bit. I did this on purpose because this is a screenshot of Paris, and you can see all these blue little dots, little triangles on the road. And then if you zoom in, if you click to the next slide, this is what it's a snapshot of the data looks like. We really track vehicles on the road. TomTom works primarily with street navigation. So we are able to track position, latitude, longitude, direction, speed, travel time of all these cars on the road. This is a screenshot of Paris, which today we have around 20% of all the vehicles on the road. TomTom is tracking 20% of all that data. And this is what powers the origin destination from TomTom and many other products. And now back to you, Kishma. Sorry, the last one, the last slide for myself. Always when we talk about data, this is a very important topic. We need to address this topic. TomTom is not interested at all in the individual. Even if we want to track the individual, we cannot do this because this has a privacy layer on the source. So our customers, the Ubers, the BMWs, the Mercedes, they already send us private data. And for us, we're not really interested in the individual. We want to know the average, the city, the urban area, the country. We want to know what's the trend, what's the average. So it's not really tracking about tracking the individual. So it's 100% super private, GDPR compliant. So it's nothing to worry about. It's a very powerful data that inputs for our customers and inputs like the Model2Go from PTV, Kishmala.
Thanks a lot for that, Jonathan. As I mentioned before, that I will also show the TomTom Move portal. So this is basically the interface
I think you're on mute.
that is used to upload the zones in the TomTom Move portal. So the zones, as I mentioned before, they are created using the Model2Go supply product, and they are then uploaded in this Move portal. And as a result, we get the OD data that Jonathan was just describing for this specific region. We can also specify for which days of the week we want this data, for how long we want this data, like for a month or 2 months, or even for a week if we want, and for which time of the day we want this data. For example, in some of the demand models, we want to only analyze the peak period. So that is also possible with the help of this. In the following slides, I will focus on the use cases that can be served using Model2Go Demand. So for example, in this one here, I have the model of Amsterdam, and I have powered it with the OD data as well. So this is Model2Go Demand, and I am showing the desire lines. So the desire lines basically help me also understand the key zones that are producing and attracting the trips. This sort of analysis can help a lot in understanding the real world movement patterns, for example. Moving on, I have this visualization for Cape Town, and here I am highlighting the zones based on their trip density. Again, trip density is a very useful measure which can allow us to assess the travel demand of a certain region. We can also study which parts of the region are low in travel demand and which parts have a higher travel demand. This can also give us an insight of what the land use of that region might look like. We can also do flow bundle analysis. Like for example, here I have the model for Manila. and I am conducting the flow bundle analysis on a main arterial, the green bars can depict the origin trips that are using this point, that are going through this artery basically, and the red bars, they depict the destination of these trips. So we can get an idea of the people using a particular main road or maybe a smaller road as well, where they are coming from and where they intend to go. All right, so this is another use case where OD demand is assigned to the network now. This is done for the region of Atlanta. And after extrapolating the demand to actual demand, the observed volumes can be compared with the designed capacities of the links, for example. And this can allow us identify bottleneck situations or the possible congestion hotspots, or we can also identify any part of the network where it is serving more than it's intended to serve. So this sort of analysis can be very helpful, and it is also very quick. As I was just talking about the use cases, so model to go demand, it can serve a variety of use cases. Here I have just an example of another one. So you can see in this one, the blue network, this is basically the bicycle network for the area of Paris. And this is downloaded from OSM, and this is overlaid on the model that is created using model to go demand. The bars on the links, they depict the assignment results, and we can get an idea of the volumes on links, and this can give us indication of how bicycle networks should be designed in different parts of the city, for example. All right, so this is a continuation of the use case example. Again, for example, if we want to check if a certain arterial is blocked, how the traffic will reroute, that can be done using model to go demand. In this example, we have closed one artery, and the blue indication, it shows us that the volumes have decreased, and the red ones, they show that they have increased, and this can help us understand how people are rerouting themselves if a certain artery is blocked for any purpose. So overall, model to go demand gives planners an opportunity to do some quick analysis. We can also do some traffic studies or traffic analysis without going into the detailed household surveys and conducting them, and then like after conducting them, we also need to analyze them and then compare it. So this model to go demand product, it enables traffic planners to do this very quickly. It can also, like for example, there are regions where we do not have a detailed strategic model. In those cases, model to go demand can serve as a very good starting base. It can also help decision makers make their decisions based on data, and improve the and make the traffic and make the, for example, urban planning more efficient and effective. So there are a lot of use cases that can be handled with this product, and we are delighted to launch it very soon, actually. So thank you all for joining us today, and now I will be answering any of the questions that you might have about model to go demand. Thanks again.
Shall we cover some of the questions, Kishmala? How do you want to do it?
Yeah, if you can take the questions regarding the data, that would be great.
Beautiful. Yeah, I see here in the chat, guys. Thanks for everybody for the questions. We have interesting ones. So the first one was, what about GPS data coming from public transport or pedestrians? Specifically for TomTom, because we have the automotive data is it's no-brainer. It's always street data. But because we have nowadays a big part of the data coming from mobile devices, of course, you get all types of data, right? You get people in buses, people inside trains, people walking on the street, for example. But because our business focus is really road street navigation, we filter out that type of data. So if it has, you can by the nature and the dynamic of the data, you can easily detect if it's pedestrian, if it's a bicycle. The gyroscope of the telephone also helps a lot. So we filter out that data because from a business perspective, TomTom focus only on the street data. And just one more about the data, Kishmal, and then I see other ones coming in. Yes, from cars, pedestrian out. Indeed, Ralph, even though this OEMs, this automotive is the owner of our competitors, we still have business with them. It's the automotive business is not very exclusive. They work with different data sources. I see another one, and I see other ones coming for the Model2Go, Kishmala. Should I just read it for you?
Yeah. Okay, so I see one
Okay.
question from Vince, which is about the validation of the data that we get. So we are getting the data at this moment from TomTom, as we just explained. So we are not validating it against any household survey data. If there is any publicly available data available for that region, then obviously we can conduct the validation based on hourly or daily levels, as you just mentioned. But this is not a part of the product for now. Yeah.
Okay. Yes. There's one which is interesting, Kishmala, connecting with the Visum, the other product from PTV. Can TomTom demand be assigned as routes on the network rather than be distributed on the network based on Visum assignment cost function? I don't know
I
if it's
can
clear to you.
I cannot see this question. If you can read it
It's the
out.
second, it's the second one. Now just another one just came in. So it's the third one from top down.
Okay.
Can TomTom demand be assigned as routes on the network rather than distributed on the network based on Visum assigned cost functions?
Yes, we can assign the TomTom demand as routes. We can use the path sequences for that. Normally, when we are creating Model2Go demand, then we are just doing the assignment based on a four-step or two-based model. But as routes, this is also possible to assign it on a Visum network. Yeah.
There's a lot of questions about the data, which is awesome. Thank you. There are ones very interesting for us, which is from there's a lot of questions coming in. Some
Yeah.
from Pradeep. How do you weight and upscale the automotive data to make representative for the population under consideration? I think this is more from the model perspective, right? So because, like I said, TomTom, depending on the city, depending on the country, of course, on average, we are tracking around 20% of the penetration rate, so of all the vehicles on the road. Some countries will be higher, some countries. So how does Model2Go, Kishmala, expand this 20% coverage to represent the whole population in a given area?
Again, as I said, that depends on the specific region. And this data is a very different for different parts of the world. So if, for example, if we are doing it for Dubai, let's say, then based on their publicly available data that is available, we will use that to expand the sample size to the original population. So, and I just saw another question from Vince, and that is about how we can trust this data if it has not been validated. Again, that depends on the region. I did not say we do not validate it. I said that is very different for different parts of the world. So, against which data we validate it, this is not like 100% for the complete world. It differs for different parts of the world. So we validate it against the publicly available data, as I said, I'm repeating myself, but publicly available data that is available for that region. Yeah.
A lot of interesting questions. So from Kemal, what is the scope of the GPS data? Is it valid anywhere in the world, or can we use it only with the companies that you have agreement with? No. So after we gather the data, Kemal, and we run average analysis on top of it, and then you can use everywhere because you're not getting direct access to the raw data. When I say raw data, you're not getting directly the data from the automotive or from the mobile, from the telephone hardware maker, for example. It comes to TomTom. TomTom aggregates, put more privacy layers, do some analysis, the OD analysis, for example. We run some analysis. So the data that it's out past the average, past the privacy, past the analysis, you can use it everywhere. There's another one asking if we can identify, Kashmala, heavy trucks from normal car data. From our side, not within the OD analysis, from a general data perspective, on highways, we have automatic detection of what is big trucks, big lorries, because it is based on the cap, on the speed limit. Or when we have source data, so the customer providing the data to us is a truck brand, for example. We have some truck OEMs as customers, so that we know 100% for sure that it's only truck data. So we have this automatic detection on highways combined with the truck source data already.
I think there's a continuation of the same one. Does TomTom data has vehicle classification and volumes for each class?
Yeah, which connects with another one which says, what about scooter data in Asia, which is very important.
Yeah.
No, we don't have this super tight, perfect vehicle classification. If it's a big truck or a small truck, delivery truck, urban van, or scooter, we don't have that because in the source data, our customer data, they don't label like that. So it's really, really a matter of we identifying that data and making a separation. When it comes to scooter data in Asia, you're totally right. That's the main type of mobility. Everything is done on scooters, so it is a challenge. But Asia Pacific in general is a big, big focus for TomTom. We're going there. We wanted to expand our market share. So we are finding ways to work with scooter data or two-wheeler data. The optimal situation for us, of course, it's when our customer, the data provider to us, already we know for sure that it's only scooters, then it makes our classification a bit easier. But today, not yet.
Yeah, and just a clarification on some of the questions. I think this would answer some of the questions already. So the purpose of Model2Go Demand is to provide with a very good starting base for these strategic models or for any demand model for a small city or country that the client or customer might be interested in. We develop the model, we integrate the demand side, we do the checks from our side that we can do, and then we deliver the model. Depending on the use case, if the client or customer is interested in more validation of the data or more like in a particular direction they want us to test the data, that is obviously possible. But as a whole, in the Model2Go Demand, we integrate the supply side, we integrate the travel demand side, and then we apply some checks from our side, and then we deliver the model. I just wanted to put it out there.
I love it. I think it makes total sense. And I would like to reinforce that message because that's the beauty of working with TomTom plus PTV. So TomTom, we position ourselves as a data provider. We are not in the modeling business. We are not in the software business. We are really, really data and service company. So we provide the data to our customers or we provide APIs, SDKs, but always thinking of data. The beauty of working with partnerships like 10-year partnership with PTV, for example, is that PTV brings in all the modeling, all the expansion, all the getting this 20% and putting to the whole population. So that's the beauty. We are TomTom. We provide the data. We have access to all of this data. And together with PTV can work on all these models, sorry, that expand to the whole city, to the whole population, and so on.
Exactly. Thank you, Jonathan.
How are we doing with time? I think we can take more, right? We can take a few
Yeah.
more questions. So there's a lot of good questions, huh?
Uh, So I see a question from James, which is asking about the cutoff where only trips from inside the territory are provided. So if you are interested in long distance trips, then obviously we increase the size of the model area. And because we need a zone from where the trip is coming from, right? So we need to generate the zone for that area where if even if it's long distance, it is possible. We just need to increase the model area size.
There's another one related only to OD analysis, Kishmala, and then I think we can wrap up. Says it generally OD data generally is only about the origin and destination and not so much about the path. In our analysis, we do identify the path. So you can find a bunch of origins, a bunch of destinations, and give it to you based on the preferred route. What is the most common route? What is the preferred path? So you can get this type of analysis as well on a street level, not only origin destination areas, but also the connecting corridors as well.
Okay.
We are coming to the 9 a.m. Mark, Kishma. I don't know if we have more time to do questions or we can. I'm happy to
We
take
can
all the questions and answer offline as well.
exactly same. Um, if you have any questions, please write them directly here as a comment, and we will make sure to answer them shortly. So I think at this time, I will again. I would like to thank all of you for joining us today, and have a very great day. And we would try as much to answer your questions as we can in the comments. Thanks a lot again.
Thanks, everyone. Have a great day.
Bye.